Thanks and good morning. Oh, this is good. I think everybody, even in the back, can hear me. Good morning, folks. I will not try to wake those of you who are still waiting for the caffeine to hit, but I'm going to go over a few things that many of you have heard before and a few things that are probably pretty new. I'll talk a little bit first about what DNSSEC actually is, why it's not been more widely deployed to date, and what to know now that it's actually appearing out in the operational world. Because there have been a lot of history that's gone into where we're at today, a horrifying amount of history. I see some colleagues out here in the room that have actually been working on this longer than I have, and we'll get back to some of the background. What's DNSSEC? All it does, it adds authentication to the DNS, uses digital signatures carried in DNS resource records created for the purpose. It assures you that the data that you got from the DNS is what whoever controls the zone wanted you to get. That's all it really does. It does not hide or encrypt anything. Also doesn't prevent DDoS or otherwise protect servers, although I think there's significant benefit in being able to trust the answer if you can validate it regardless of where it came from. So I think there's some intrinsic protection for servers in that, but that's not the primary purpose. The primary purpose is simply to authenticate the data. The problem what problem does DNSSEC really solve? As many of the people in the room know that have been doing operations for a long time, DNS is a very old protocol in Internet terms. It was written for a different world, and in today's environment, its virtues of simplicity and low overhead can leave the protocol wide open to abuse. The base DNSSEC protocol will believe pretty much anything from pretty much anybody. Once it's believed a bad answer, a resolver will keep repeating it to anybody who asks. We've done a lot to make DNS more resilient over the years, a little bit less trusting, but the underlying issue remains. It's not very hard to make DNS lie to people. This is a serious problem, and yet we've had a hierarchy of problems for such a long time that it's not been clear this is something we were terribly worried about. Because attacking DNS is simple, but attacking other things has been even simpler. We've got social engineering attacks on users. We've got worms and viruses subverting machines. We've got attacks on networks and network elements. So for a long time, this was not making anybody's hit parade of things that keep administrators awake at 3 in the morning. So there we were. The current set of DNSSEC standards came out in 2004, RFCs 4033, 4034, and 4035. Support for DNSSEC in widely used open source name servers also appeared in 2004, and we waited. It was a lot like tossing a rock down a well with no idea how long to wait for the splash. DNSSEC obviously incurred some costs, bandwidth, cycles, clue. Adding new capability always does. And we knew at the time that the benefits weren't obviously cost-effective for anyone. There's a well-known economic analysis that actually applies to multiple technologies that basically says that deploying technology that's good for you really isn't enough of an incentive. We really need a pressing problem because everybody knows such things are good for them, but you have to have the cost-benefit analysis all scored out. So why are we having this conversation again? I mean, many of us know we've had this conversation before. This is a part of the story that I think everybody knows, so it'll be quick or at least entertaining. Early in 2008, a guy named Dan Kaminsky discovers a way to make a very old cache poisoning attack very, very efficient. The problem where DNS lies to you, now it's a problem we have, because all of a sudden it's easy. And now we get to find out if DNSSEC is really a viable way to solve it. There's an old joke in the theater that overnight success generally takes about 7 to 10 years. So this is what has happened at DNSSEC. It finally has become an overnight success. There's, in the last year, a handful of signed TLDs appearing. .SE was the first large TLD that was signed. I believe they went live last year. .gov was signed earlier this year. .org has put out a production signed zone in the last couple of weeks. Many more TLD operators are evaluating, making plans for .mil, .edu, the .uk domains, maybe eventually .com. And there's an important item that's sometimes overlooked as a recent development, that IANA is publishing trust anchors, the keys, for those signed TLDs. The design of DNSSEC assumes a signed root, so it's a bit awkward that we don't have one. But the most important thing is to be able to start the validation chain with data you trust, because the validation chain follows the DNS hierarchy, the delegation chain. So DNSSEC assumes that you can follow DNSSEC validation through the namespace, through the same hierarchy. The important thing is that you start somewhere you trust, and PGP signed text from IANA can be configured safely and easily into your name servers if you're so inclined. The important thing is that it came from IANA by a path you believe. So there's even a way to get those TLD trust anchors in a trusted and reliable way. Oh, and the root zone, which has been the subject of a great deal of speculation for quite a long time now. The authority over the operation of the root zone, including DNSSEC, is the U.S. Department of Commerce, National Telecommunications Information Agency, I think, NTIA. They were told about DNSSEC quite some time ago, and they've been doing their homework. They ran an inquiry process last October seeking public comment on whether to tell VeriSign and ICANN to proceed with signing the root. A lot of their focus was on management and control of the key sets involved, which has political implications. It was, it's been clear for very early on that there will be two sets of keys involved in. It's optional, but most zones will want to use both zone signing keys that roll fairly regularly and key signing keys used to authenticate the zone signing keys. And because control of the root zone is a sensitive issue, control of the keys and the exact topology of how keys would be managed and interact was clearly a sensitive issue. Almost 2 weeks ago, NTIA announced a cooperative effort with ICANN and VeriSign to move towards DNSSEC deployment in the root. The stated intention is that there's an interim plan to be refined by experience, but the goal is a signed DNS root zone in 2009. I think this is a very aggressive goal, and we'll be interested to see how that plays out. But they did say a little bit about the mechanics that they foresee for that. Not everything is known or decided about signed root operation yet, but we know a few things. ICANN's role is to operate IANA and to conduct due diligence and follow its processes as far as any change to the root zone. VeriSign will continue to generate the zone data that the root servers pick up from the VeriSign servers and will manage the zone signing keys. NTIA will continue to audit changes to the root zone and will make the final decisions on management of the key signing keys. They've told ICANN and VeriSign to go figure out exactly how to do that, and will make the final decisions as to the operational details on that. So that's serious forward progress. This is good. There's a little bit of early experience with .gov, because I went live in February. There was actually a directive that came out last September saying, you guys go do this. And the goal is for subdomains to be signed by the end of this year. They did use NSEC 3, which was a variant on the DNSSEC standard that allows prevention of walking through the zone. They prefer that you not be able to download the full .gov zone. But that seems to be working well. this is interesting. The most interesting thing about watching .gov has been, this is the U.S. government. They can tell people to just go do this and then watch the consequences play out. The interesting thing to me has been how little drama appears to have ensued. Things appear to be working reasonably well. Key changes and so on do not appear to be causing a lot of drama. And this is good to see. However, we're beginning to see some of the things that we're going to need to be aware of. We're getting into some new stuff. One thing to know about DNSSEC is that it depends on the eDNS0 protocol extension for safe operation, because DNSSEC data is large. Signatures take a lot of bits. eDNS0 allows for both a set of options to be set that are otherwise not part of DNS, and for packet size negotiation between a client and a server. DNSSEC has an option assigned that's used to say, I can handle DNSSEC data, and because eDNS0 is required to carry the option, you can't signal readiness for DNSSEC without eDNS0. There's the assumption that large answers will fit the negotiated packet size. The capability is set by default in a lot of fielded software. The DNS0 packet size negotiation starts a lot larger than traditional DNS packets and falls back to smaller and smaller. It can go down to 512 bytes. There are possible configurations where the DNSSEC answer doesn't fit into the negotiated packet. The problem with this, in many cases, is that the triggers fall back to TCP. Lots of DNS relying on TCP will not scale. And there's some possible indication that this effect has been seen in the wild. And there's now a discussion going on among DNS protocol folks, within the IETF working group on DNS, and among operations folks that have looked at this on how to avoid the problem. There may be a small change to the protocol required. There may be operational changes we can do. But there's a set of nonsensical scenarios we have to make sure we prevent in wide use. Another thing to know, another set of issues to be aware of, there's a lot of network elements between the pieces of your DNS topology in a lot of networks. For instance, many firewalls think they know what DNS packets look like. I heard that. DNSSEC answers don't look like DNS to some of these devices. This can be a problem. It's not specific to DNSSEC in most cases. It appears to be more specific to eDNS0. But there's a little bit of a problem. There's a lot of small office, home office gear, a lot of end devices that is capable of the right behavior but does not behave properly out of the box. For perfectly good reasons, the out-of-the-box configuration on a lot of these devices is very conservative. And being too conservative in what you expect can lead to rejection of perfectly good data, and in some cases drop DNS answers. So we really have to admit here that we're introducing a significant change into the ecosystem, and this kind of caution in examining these kinds of issues is really important. There's a set of things we still don't really know. We don't know yet what uptake is going to be for DNSSEC further down the DNS hierarchy. There's some, as we gain experience and as we look at what the costs really are, we also get more experience with the benefits. .gov has a few dozen signed delegations, but the operators of .gov subdomains are under a mandate. .org hasn't yet started accepting signed delegations, although I'm told that that's in the near future. And we'll have to see how much it really helps to have DNSSEC deployed. Whether not using it will become a problem. Will you be more of a target if you're not signing your data? And how resource use profiles really do change. DNSSEC, it becomes more widespread. The interesting questions to me, having worked on this as long as I have, is how does it scale? Because that's always the interesting question about any change in the internet ecosystem. And what's enabled by it? Does a more trustworthy DNS enable other things we haven't thought of yet? A couple more things that we're going to have to develop experience with. Key management is really important. Rollback is hard. As with any PKI, you really have to think about what you're trying to accomplish and what the costs really are. We're still evolving the best practices on that. There's also a question of how you publish your public keys for a signed zone if your parent isn't signed, because a protocol assumes that there'll be a chain of trust, a hierarchy that follows the namespace. There are several possible ways around that, and you can talk about that separately, but there's not really room here to go into that in detail. There's another class of issues around the fact that it's still hard to get people to pay for security. Even though cache poisoning is cheap, risk mitigation is comparatively expensive, so it's not clear where it fits for other providers of services around DNS, for registrars and hosting providers and others who can't afford to give away more work. So how the business case is going to play out is very interesting. So kind of to conclude, I remain optimistic. We're looking at some pretty complex technology, but it does solve a problem we have at what looks like manageable cost. And I do believe we'll find that a more trustworthy DNS will enable some things that we just don't even see yet. Because we take so much for granted. We act as if the DNS is trustworthy today. It's not. And when we do have infrastructure that's slightly more trustworthy, I think there are some things that will become feasible that haven't been yet. So I guess the takeaway here is, if you've been waiting for DNSSEC to be real, please consider that the time is now. If you manage DNS zones, look into signing them. Look into what that gets you and what it costs you. If you run resolvers, particularly large resolvers, look at what will happen when you're receiving signed data, what you're relying on, what your customers need. And I'll ask real quick, I know I've talked to some of the folks out here who have been experimenting with DNSSEC, who have done some work recently, playing with signed zones or resolvers. I know Chris from Comcast, and anybody from Affiliates that's here who's been working on .org. So I'm not seeing a lot of hands, but seek each other out. And there are folks in the room who have some operational experience and some testing experience and so on. There was also a symposium in Washington last week on some of the issues around signing the root and what happens next, because we've been focused on that for so long that there are some issues that need to be discussed once we can assume a signed root. So the results for that will be out shortly. Stay tuned for that. I'll drop a note to the mailing list when that's out. And most of all, I hope we'll be seeing some early adopters sharing a lot of experience now in the pretty near future, so especially if we ask them to. So questions, comments, hopes and fears?
Suzanne. Dave Moyer. I'm wondering, I was reading your slide where you're talking about eDNS0 and packet sites negotiation, and I was wondering how much the protocol actually, it's not a DNSSEC expert, as you well know, but I was wondering how much the protocol depends on PMTU discovery for that negotiation that you're describing.
Not directly. And I would have to go reread the RFC, to be honest with you.
Okay. Because personally, I find PMT discovery kind of weak, and so if you put that in the path of something you need in your protocol, then you're kind of like, you got a weakest link in the chain and all that kind of stuff.
There is kind of a weakest link problem there.
Just curious. Thank you.
Hi, Rob Seastrom, and I'm speaking on my own behalf, not on behalf of any employers past, present, or even future. RFC 2671 is the DNS0 RFC, and I
Thank you.
had not read through it for years. It's been around for almost 10 years at this point. And nevertheless, one thing, in addition to a big uptick in TCP queries that have been seen in the wild, subsequent signings of zones, like say a six-fold increase, there's also been a smattering of firewalls, to expand on your comment about stuff that's pegged to EDNS0 rather than to DNSSEC per se. Mm-hmm. Firewalls out there that believe that no DNS reply should ever be have a payload any bigger than 512 bytes.
Right.
And that's something that's inherited from the ARPANET MTU of 576 bytes. That's something that's just completely not relevant today. And yet, there's a lot of stuff. I don't know about software revision levels or anything like that, but there's certainly firewalls that have been deployed recently enough that they're still in use that still believe that result in tech support calls. And that's a very important thing for folks to be cognizant of. Right. Is that you'll get stuff truncated or dropped more likely by the firewall because it looks like it's wrong. And one other point I was going to make, and I'm forgetting what it was. I may jump up here if someone else is talking.
Well, on the EDNS0 point.
I remember what the other point I was going to make is that if you think you aren't doing EDNS0 because you haven't turned it on or something, if you've upgraded your resolver software in the past 5 or 8 or 9 years, you're doing it. So it does it by default. I'm correct, right?
Yeah, there is a negotiation that will allow you to fall back to if the server side does not understand EDNS0.
Right. But modern caching resolvers are going to be doing it by default.
Right, and what you want to do, there's 2 points that I can make along those lines. One is that there has actually been some empirical research done, and I should just add the reference onto the slide pack online so people can find it. But there was a study done by Nominet and Core Competence, I guess, that looked at a bunch of small, SOHO devices, and mostly they found that you can get the right behavior out of the boxes, but not by default, which I did sort of go into a little bit. The other piece of the picture, though, is I think the takeaway: different implementations behave differently with respect to EDNS0, path discovery, packet size negotiation. There's a great deal that's set up in the specification, but as always, what's really in the field and how it actually behaves is something you have to go look at what's happening in your network. And the flag I can really raise here is, even if you think you understand how simple DNS is in your network today, it might still be something you need to look carefully at. How is it going to behave when the world changes around you?
Hi, Rob Austin, ISC. Just to the question about PathMTU earlier. PathMTU is largely irrelevant for UDP-based DNS because the large packets are the responses generally, and the ratio of clients to servers is such that the server effectively has no repeat traffic to the same client, so there's never any discovery phase.
Thank you. He's the man. He knows.
Igor with Yahoo. Has there been any studies done on how many users this will break? I mean, clearly, SOHO devices have problems, a lot of firewalls have problems. Have there been any studies done on what the side effects are going to be?
Yeah, there have been a couple of different. There's a study that I referred to before, and I'll make sure that URL is available, on what some SOHO devices will do. There is also, this is what I refer to as the early deployment experience, and why I'm happy to see some folks in here that I know have been experimenting, because that's the kind of thing that is actually very current right now, that people are looking at in detail at what the behavior will turn out to be.
I guess
I think that I'm pushing back a little bit on the question of have you looked at how many people this will break? It's a little bit. I want to break that apart a little bit, because there's multiple pieces of that, and I think there's a lot of active study and discussion going on.
Okay, so somebody's actually looking at,
yes.
Forget changing values. If you turn it on right now, how many people drop off the map? if you turn DNSSEC on with an answer that's going to be approaching 4K bytes, what happens? Right, but if people begin asking for it, what's the side effect? Behind the Soho device?
Rob? Mike?
Yeah, or behind a firewall?
Okay, so the discussion between Igor and me was, hopefully they know what they're asking for if they're asking for it. And Igor's response was, behind the firewall. And I said, yes, well, that's the corner case.
Right, so do we know how much the corner case comprises? Is it 0.0025% or is it 2%?
So the DNSSEC discussion is usually not between the resolver or between the resolver library and the cache. It's between the cache and the world. So.
Yeah, no, I'm happy to listen to this also, but Chris is up in the back, at the back mic, and might actually have something else to, might have some data.
Yeah, so Chris Griffiths, Comcast. So one of the things that we've been looking at, specifically Ray Bellis from Nominet published this article, and Suzanne was talking about it, was for testing for home gateway Soho routers. And he's also got an active draft that's been open for specifically DNS proxies and best practices in that arena for getting traffic and dealing with large DNS query sizes. So that's something that folks should definitely look into and also, supporting. But we've also done our own testing, and it does have issues.
Is there, Chris, if you don't mind me asking, I'm hoping you'll say that there's some plan to continue to publish and share some of that experience.
Yes, yeah, we'll be sharing that.
And I've also been assured affiliates and .org, one of the reasons for, there's the public benefit piece of what PIR and .org are about. That means that I've also been assured that they will be publishing results and observations from their experience as early. They're considering themselves to be early adopters and are eager to contribute their experience.
Michael Sinatra, UC Berkeley. So really sort of 2 points related to the most recent discussion. One is that in terms of things like path MTU discovery or the overall size of the packet, obviously path MTU discovery is not very relevant because you actually end up with fragmented UDP packets. So it's not just a question of whether your firewall understands that DNS packets are larger than 512 bytes. It's a question of whether your firewall can deal with fragmented UDP packets and reassemble them. And that even includes host-based firewalls that are just acting as simple packet filters.
Right.
It's not just stateful firewalls. So there's a lot of stuff that goes wrong on the firewall side of it. The other issue is with regard to what breaks when you turn it on. Usually people know what's going to break because they're turning it on their resolver, on their caching resolver. So they turn on validation and start setting DO bits, and it gets back big answers from assigned zones, and then they stop working. And usually, if you have it, if you kind of understand that I'm turning on something big, I'm going to test it, and then it stops working, you're going to figure out pretty quickly that that's what's going to happen. So it's not something that's somewhere out there. It's going to start happening, and all of a sudden things won't work. Hopefully the people who are implementing it will be able to figure out and get immediate feedback as to whether it's working or not.
And this is the thing that has changed in the last few months and over the last year, as opposed to the entire history of this effort before that, which is that we're getting operational experience, people actually getting out and doing that and looking at the results.
I'm really speaking, Licia Zhang from UCLA. I'm speaking for someone else, Eric Oswald, who's done lots of DNSSEC deployment management. Suzanne mentioned about the references. You forgot the URL. I don't know if that's the one you had in mind. It's secspider.cs.
Right. That wasn't what I was thinking of, but that's another good one to have.
Yeah.
And I'm realizing that what I'm really missing here is a bibliography slide that I can, I think, ask the Merit folks to add to this presentation online.
Yeah, so let's just say it so people can remember. secspider.cs.ucla.edu. It's very easy.
Or Google for
Yeah,
Sex
Google for
Spider.
it, Sex Spider.
Yeah, SEC Spider. Okay, and I'm not seeing anybody else moving, and I think the time slot's up, so Paul and then Rob. Rob gets the last word, and
Oh, no, Paul should always have the last word.
yeah, figure it out, guys.
You were at the mic first. Go ahead.
My final thought on the validation, as somebody who is doing validation right now because it's a good idea for me at work. We're not going to see the true impact of things screwing up while it is still difficult to do validation. And by difficult, I mean manual intrusion and having to make sure that your ITAR list is updated on a frequent basis, the DLV is configured properly. This is the kind of the driving a Model T versus driving something with an automatic transmission era in DNSSEC. And when it becomes with a signed route, load one certificate, change a line in your file, fire it up.
And it's all automatic from there, right?
It's all automatic, and it's all automatic breakage, because some software vendor somewhere is going to push out an update, and it's all going to be in there. And that's when the wheels come off.
Which is why it's really important that we understand what we're doing long before then.
So, as the author of RFC 2671, I want to apologize for depending on IP fragmentation long after it had been proved to be a disastrously bad idea. We're still paying for that. We will pay for a while yet. Nevertheless, this stuff can be made to work. Joao Damas spoke about DLV at the San Jose NANOG a year or two back, and I don't want to get into it now except to say it was meant to give people a way to start deploying DNSSEC before their parent zone, which for most of us is .com, was signed. The two notes are, first, VeriSign has announced publicly they intend to sign .com in 2011, which would be good. And second, DLV is working in an unexpected way, and that is, I guess I should have expected this too, since two strikes. Instead of giving people a chance to deploy early and benefit from whatever additional application behavior they can wire into, gee, I got a secure response, I think I'll trust it now. What we're seeing is that DLV is allowing a lot of people to start getting DNSSEC responses, and it is breaking everything. DLV is taking a hit for that, which is unfair, but you can't have a firewall that doesn't pass fragments. We're just the first people to come along and tell you that. You can't have boxes in the middle that rewrite DNS packets or somehow recognize that a DNS packet must not, a query must not have an additional data section. But even though you can't do it, you've been getting away with it, and we're the ones telling you actually you can't do it. And there's going to be a lot of that. A lot more stuff is going to break, and it'll be a little bit like V6, where the early adopters are going to make things safe for everybody else. I think the reason we're now finally seeing the overnight success is that a lot of that early work has been done. And I just want to second what Suzanne and others have said, which is turn this stuff on. It's not that hard. It's harder than it should be, and it will get easier. A lot of people are working on tools in this area. Turn it on and start playing with it, because it's definitely coming.
Okay, thank you.